Today we solve a problem to fit binomial distribution. We'll take a problem that is 4 unbiased coins are tossed 128 times. Find expected frequencies of number of heads obtained. So here 4 coins are tossed. So 4 coins are tossed means n is 4. And what are the outcomes? What is first probability term? So remember, binomial distribution is a discrete random variable, discrete frequency distribution. Okay, so the first probability term when we toss a coin in a binomial distribution start from 0, 1, 2, 3, 4. That is x takes here 0 to 4. The range for this problem is 0 to 4. And now we have to find the expected frequencies, that is theoretical frequencies, not observed one. Just what result may come. So that can be identified by, for p of x, for all x values we have to identify, and if you multiply it by n, capital N, that is 128 times we are tossing 4 coins. So 128 into probability of each of random variable, we get theoretical frequencies. Now here random variable 0, 1, 2, 3, 4 up to 4 we get. Then p of x. So probability we have to identify for each of x values. Then theoretical frequencies, that is t of x is equal to n into p of x. Tx is equal to n, capital N, into p of x. So probability mass function here. So we consider x number of heads obtained in a toss of 4 coins. So when we toss 4 coins, how many number of heads we get? That takes here x. So x tends to binomial distribution. Okay, binomial distribution. And probability of success. Here unbiased fair coin is tossed. So when unbiased coin is tossed, the chance of getting head and tail both are equal. So here n is equal to 4 and p is equal to 1 by 2 or 0.5. Now probability mass function, p of x is equal to ncx into p raised to x into q raised to 1 minus x, where x is equal to 0, 1 till 0, 1, 2, 3 and 4. Now first probability term, p of 0 is equal to, so I will fill the values here. P of x is equal to 4cx into 0.5 raised to x into 0.5 raised to 4 minus x. So when p and q both are equal, 0.5 and 0.5, so if we take the common here, so 0.5 raised to 4 minus x plus x, so it will become 4cx into 0.5 raised to 4. 4cx into 0.5 raised to 4. So x minus x will become 0. Now first probability 0. P of 0. So 4c is 0. table, binomial distribution table. Okay. That 0.5 raised to 4 is common for all the values. I will identify it. 0.5 into square cube raised to 4. 0.0625. 0.0625. So 4 here P0. 4C0 into 0.0625. So 4C0 is 1. 1 into 0.0625 is equal to 0.0625. So first probability P of 0 is equal to 0.0625. Now theoretical frequency Tx. So Tx formula is T of 0 is equal to N into P of 0, that is N is 128 because coin is tossed for 128 times into 0.0625. So into 128 we get 8. So first theoretical frequency is 8. Second probability now. P of 1 is equal to 4C1 into 0.0625. So 4C1 is 4 itself into 0.0625 is equal to 0.25. So T of 1 is equal to 128 into 0.25. So 32. So second probability is 0.25 and theoretical frequency is 32. And next P of 2 is equal to 4C2 into 0.0625. So 4C2 is 6. 6 into 0.0625 is equal to 0.375. So third probability term is 0.375, and into 128 if we do, we get 48. Third theoretical frequency is 48. And next T of 3 is equal to 4C3 into 0.625. So 4C3 is 4 itself into 0.0625. We get 0.25. And last one, T4 is equal to 4C4 into 0.0625 is equal to 1 into 0.0625 is equal to 0.0625. So here it is 0.25 and 0.0625. And 0.25 into 128 is 32 and 0.625 into 128 is 8. Now theoretical frequency total should be equal to how many times we tossed the coins. So that is 128 times we have tossed the coins. The total must be equal to 128. So 32 plus 8, 40. 40 plus 48, 88. 88 plus 32, 120 plus 8, 128. So, and here this total will be equal to 1. So, this is how we fit binomial distribution. And remember here, the frequencies are in bell shape here. So 8, 32, 48, 32 and 8. They are symmetric. So here in theoretical frequency distribution for binomial distribution, the distribution is always symmetric. It is not skewed for either positive or negative. Always it is, for theoretical distribution, always it is symmetric. Now we'll discuss a problem where observed frequencies are given and fitting binomial distribution to that observed with help of that observed frequencies. Here no observed frequencies, just it is an probability assumption. So if we toss a coin, we get the chance of getting head and tail are equal 0.5. But when in reality, when we toss the coins in reality, the probability of getting head is not 0.5 then. It may be more or less than 0.5. So in such cases, with help of observed frequency distribution, we'll fit a binomial distribution with help of recurrence relation. So here this distribution is also have been identified, that probabilities were identified by the recurrence relation also. So even this one, if you identify the first theoretical frequency here, so 8, with help of this 8 only, without probability terms also, we will identify the next probabilities and even next theoretical frequencies. So but we'll take a problem now, we'll solve that.